Now I will discuss about pulley or belt friction. So in one of my previous video we discussed the frictionless pulley. If I write here uh, frictionless pulley. So what is frictionless pulley? That means if there is a pulley here and I have an object say here and I am pulling it somewhere here. So frictionless pulley, that means like there is no friction in the surface. There's no friction. In that case, say whatever the weight, say if the weight is 100 pound, this will be how much? If there is no friction, both side of the cable, the tension or the weight is equal. That means the tension here is 100 pound when there is no friction. Now we finished those discussion, or at that time I told that same cable, same load. So whenever this cable goes, the load must be same because there is no friction. Now the same thing, but there will be some friction here, some friction in this surface. There is some friction. Let us see the frictional coefficient is mu s and mu k. What is mu s? If my belt or pulley doesn't move, if this belt doesn't move, then it will be mu s. And if the belt moves, then it will be mu k. That is like static versus kinetic. Okay. Now the question is, so there's an object here that is 50 pound and I am pulling it here T. What is the value of T? That is the main question. Now, as you know that friction depends on the motion. It is always opposite to the motion. So just by giving this problem, I cannot ask what is the value of T. I must tell you what is the motion of this object. Is it going up or is it going down? That means, okay, so that means my body is going down. I need to hold in place. If this is the case, that means my body is going down, I am holding it. I am trying to hold the body in place. That means the body is going down, I am holding in place. In that case, my frictional force will be this way. This will be my frictional force because my body is going down. Okay, so okay, in that case, see, this friction and your force, these both are resisting the motion downward. So now, whose force will be higher, this force or this force? Obviously this will be higher. The reason is this and this, they both are resisting the moment. So this will be higher, this will be lower. Now which one is higher, which one is lower? If you can identify your problem is 50% done, you must identify it. If the case is opposite, opposite means the question is to lift. If I want to lift this object, what is the value of T? If the question is this, if I want to lift this, what is the value of T? So if I want to lift it up, that means motion is this way. So in that case, my frictional force will be that way. So T will be equal to this plus this. In that case, T will be higher. So if I write in terms of like letters, this is higher, and this will be lower, or simply like low and high. So hopefully you understood like when this force will be lower than this or when this will be higher than this is all about the motion. So when you get this kind of problem, friction problem in pulley, like first try to find it that which way your motion is. The frictional force is opposite. Okay, so now, okay, so what is the equation to solve it? Simple equation is T high equals T low e to the power mu theta. This is the equation. T high equals T low e to the power mu theta. Mu means the coefficient of friction. If it is static, then mu s. If it is kinetic, then mu k. So I just wrote here mu. What is theta? Theta is the angle of the belt or the pulley. Here you can see it start touching here and it ends touching here. So this is my angle. It is 180 degree. Now this should be in radian. Any theta, if we use theta in any equation which doesn't have sine, cosine, tangent or this kind of parameter, only a like separate or isolated theta is always in radian. That is something to remember. I do not know that. I never saw that any theta which is not with sine, cosine or tangent is in degree. No, I see most, all of the angles, if it doesn't have sine, cosine, tangent, it is in radian. So here it will be radian. So T high is T low e to the power e to the mu times theta. So this is the equation. Now you have to find it. Which one is T low, which one is T high. Say, okay, if I start from beginning, okay, that means say not this one. The problem is I want to hold the object in place. That means the body is going down, I am holding it. So body is going down, that means my friction is this way. So we both will resist the motion. In that case, this will be higher. So for answer of this, if I am to solve this problem, then my 50 pounds will be higher and my T will be here, low e to the power. Say this value is given 0.3, 0.2. So say this is given 0.3, this is given 0.2. Then e to the power 0.3. Why 0.3? Because it is not moving. I am holding in place. It is not moving. So 0.3. And what is my angle? Pi. Pi is 3.1416. Okay. Then you can find T low. Now the same problem, the red one. The red. If I want to see what is my force to lift it. If I want to lift it, my frictional force will be that way. That means I need to pull it, I need to exceed that friction and this. In that case, so T high, T low, e to the power theta. In that case, my T low will be 50 pound. E to the power 0.3 pi. So in that case, my T will be T high. So hopefully you understood this equation. T high equals T low e to the power mu theta. Which one is T low, which one is T high? It depends on the impending motion. If you want to hold the object in place, then this will be T high, this will be T low, because it is going down, you are holding it back. So your friction is helping you. So you have to think about it, okay? So in the next video, I will solve another example. Thank you.